These notes are on operations on rational expressions and functions. So just like rational numbers, what we think of as fractions generally, we can add, subtract, multiply, and divide rational expressions. We can also solve rational functions. So let's jump right in. If you remember, when you added fractions, when you added rational numbers, you had to have a common denominator. So the first thing I'm going to do is I'm going to rewrite both of these with their denominators factored. So I have 3, I can pull out a 2. This is x plus 2 quantity squared. And then factor x squared minus 4 to be x minus 2, x plus 2. So now I'm going to look for my lowest common denominator, just like I did when I was dealing with rational numbers and adding and subtracting. So I can see that I have a 2. I can see that I have an x minus 2. And I can see that I have an x plus 2 squared. So now my job is to fill in what's missing from the bottom and multiply the top and the bottom by that value. So what is missing from my first fraction? I have the 2, I have the x minus 2, but I only have one x plus 2. So I'm going to need to multiply this by an x plus 2 over x plus 2. Remember, I'm not changing the value of this fraction, which means I have to multiply the top and bottom by the same thing, because x plus 2 over x plus 2 is 1. In my second fraction, I am missing the 2, and I am missing the x minus 2. So now that I have filled in what I'm missing, I can actually go through the process of multiplying it out. Now, I use a little bit of shorthand when I'm doing these fractions because I don't like having to rewrite things over and over and over again. So I'm going to say I have 3x plus 6 all over my lowest common denominator plus 2x minus 4 all over my lowest common denominator. Because I have a common denominator, oops, I should have some equal signs here, I now can combine these and I can get 5x plus 2 over my lowest common denominator. And then my last step is to plug back in what that lowest common denominator is. And we leave it in factored form. So 2x minus 2x plus 2 squared. And one of the reasons we leave it in factored form is because we're always hopeful that the top of the fraction can be factored and then things can cancel. In this case, 5x plus 2 does not factor. So I'm done with that one. Second example, in this case we're doing some subtraction. So I start the process exactly the same way. I factor my denominators. And then I'm going to look for my lowest common denominator. I have an x minus 2. And I have an x minus 2. There's only one of each of them, so I don't need more than that. I have an x plus 2. And I have an x minus 4. So now I've got to figure out what it is that's missing. So in my first fraction, what's missing is I have the x minus 2 and the x plus 2. I'm missing the x minus 4. So I'm going to multiply the top and the bottom by x minus 4. In my second fraction, I have the 4 and the minus 2, but I need the plus 2. So I have x plus 2 over x plus 2. So now I multiply 3x squared minus 12x all over my lowest common denominator minus 6x plus 12 all over my lowest common denominator. This is a part that I have found in the past to be a place that students mess up on. So just be aware that there's a place here to make a common mistake. This subtraction sign means I'm subtracting this whole thing, which means when I write it as one whole fraction, my lowest common denominator, I actually have to distribute the negative. So it's actually negative 6x minus 12. Now I can combine my like terms. over my lowest common denominator. I'm going to factor my top. I can factor out a 3. And that can't be factored any further. There's no number that, two numbers that multiply to be -4 and add to be -6. And so then I just write in my lowest common denominator written out. The next problem we're going to look at is dividing. So we have some multiplying and dividing. Just like with multiplying and dividing rational numbers, what I'm really looking for is I'm looking for things where I have ones, where I have a number divided by that same number. So the first thing I need to do in order to see that is I need to have all of this be multiplication. So two things that I'm going to do at once. The first is I'm going to factor the top of my fraction and the bottom of my fraction. I'm going to change my division to multiplication, and then I'm going to rewrite my second fraction. Remember, when dividing by a rational number, it means the same thing as multiplying by the reciprocal. So I have my first fraction still is b minus 5, b minus 1, and my second fraction is b plus 5, b plus 1, all over b plus 2, b plus 1, b minus 5, b plus 5. Remember, since I'm multiplying the fractions, really I'm multiplying everything on top along with everything on the bottom. So now I'm looking for ones. Well, I have a b minus 5 and a b minus 5. So b minus 5 divided by b minus 5 is 1. b plus 5 divided by b plus 5 is 1. b plus 1 is 1. So I'm left with a b minus 1 in the numerator and a b plus 2 in the denominator. And I don't need to use parentheses anymore since there's nothing being multiplied to the b minus 1 on the top or the b plus 2 in the denominator. Our fourth example, again, we have a problem in which we are multiplying rational expressions. So again, I'm going to do my exact same process. I'm going to factor. So x minus 8 is already factored. The denominator I have x minus 8x plus 6. Since this is multiplication, I don't need to do any flipping. So immediately I can start writing this as multiplication. Whoops. Let's factor out a 4x. 4x, which leaves me x plus 10, and then the bottom is x plus 10. So right there I'm dividing by the same thing, and I'm dividing by the same thing, which gives me 4x over x plus 6. In our last example, we're actually going to solve a rational function. So we have an addition problem, which means I need a lowest common denominator. I kind of also just need to get rid of those denominators. So what I'm going to do here is I'm going to factor just as we've been doing. Oops, it turned into a 6. It should be a t. t plus 1 equals 1/3. So my lowest common denominator here is 3, t minus 1, and t plus 1. So what I'm actually going to do is I'm going to multiply each and every one of these fractions by this lowest common denominator. So I'm going to multiply by the LCD, multiply by the LCD, and multiply by the LCD. But remember, in this case, my LCD has a 3 and my denominator has a 3, and my LCD has a t minus 1 and my denominator has a t minus 1. So I'm really only left with the t plus 1. In this case, my denominator has a t minus 1, so those cancel when I multiply, as does the t plus 1. So I really have just 2 times 3. And on this side, it's my 3's that cancel, so I still have a t minus 1 times a t plus 1. So now I multiply everything out. t squared plus t plus 6 equals t squared minus 1. I can cancel the t squareds because they're the same, so I'm left with t equals -7. Now, there's one catch whenever I do a problem where I'm solving a rational equation, which is that I have essentially multiplied this equation by some value that could turn out to not be, that could be 0. So I want to make sure that none of my answers make my denominators 0. So if my denominators equal 0, t would equal 1 or -1. But here I got t is -7, and so I am safe. T equals -7.